Hello, thanks for the introduction. My name is Dirk Reiners, and I would like to talk a little bit about my work. So, first about me, I am an associate professor in computer science. I joined UCF in January 2020. So to say that my first semester was interesting would be one of the understatements of the year. Before coming here, I worked at the University of Arkansas Little Rock, University of Louisiana Lafayette, and Iowa State University. But really, so my real start was at the Fraunhofer Institute for Computer Graphics, which is a private research institute for applied computer graphics and one of the largest computer graphics research groups in the world. So a lot of my work is motivated by looking at applications and trying to see how we can use computer graphics to help people solve problems. Here at UCF, I lead together with my colleague Carolina Cruz-Nera, who's going to talk in 2 weeks about her work, the Visualization and Mixed Reality Research Group. That's not the final name, but we're still in some negotiations about corporate sponsorship and other things, so we'll have a final name hopefully soon. We have since yesterday a lab in the computer science building, and for larger installations, we have a space in the research part that hopefully we're going to remodel over the summer. On the teaching side, I've only been here for 1 semester. So far, I'm teaching the real-time realistic rendering course, and we're going to see what other courses are going to be in my future. Motivation for my work is really based on the fact that nowadays we don't have the problem that we don't have enough data anymore. I'm sure many of you have that problem that you have too much data. There's just everybody can generate, measure, simulate, and collect so much data that it's very hard for people to understand it. And there's a lot of machine learning that tries to help with that. But if you really want the human to understand it, the most effective way to convey lots of information is the visual sense. Our eyes are really the high bandwidth pathway into our brain. And because we live in a 3D world, we have some inert 3D understanding. So we're also looking into 3D immersion to increase the amount of data we can see. So to do that, we use virtual reality, and not just virtual reality in general, but also interactive visualization. And I'm going to talk about those in the coming slides. And both of those live at an interesting point because it's the intersection of both accuracy. We want to have a world that looks real, that looks accurate, but we always have the human in the loop, and we can't slow down the human. To make the human feel immersed, to make it feel real, we have to have performance constraints that satisfy the human perception, which for visuals is about 60 to 90 frames per second. For haptic, like touch, we have to go into thousands of computational updates per second, which is not a trivial problem for a large world, because we want to work with large data. How can we present large data in a way that allows interactive exploration? And how do we display that? So one of the problems that we have is many of our colleagues think about us as the people that make the pretty pictures, which is true. We make the pretty pictures, but we do a lot more than that. We worry about the whole system, software, hardware, and the end user, and how can we make this effective. So some examples of things that we work on, some of the interests that we have. I'm interested in display systems. When you hear virtual reality, you think head-mounted display, but really what we want is human eye resolution and a large field of view for a group of users, because we usually work with more than one person these days, and all of that at low cost. And we can't do all of that at once right now, but what we do when we do build hardware, we don't usually start from scratch. We combine off-the-shelf or common off-the-shelf components. And one example for that is what we see here, which is the high wall, which is a system that combines lots of simple projectors to generate a very high resolution 3D projection wall. And when I say very many, this is what it looks like behind. We had to combine 48 projectors to give us the resolution and the brightness that we needed. And the result is really pretty impressive. Having this kind of resolution where you're approaching the resolution of the human eye really makes a big difference in how immersive and how real things look. But of course, this is a very expensive system. On the other hand, we're also looking into immersive systems that surround the user at a price point that is more affordable, that people can actually put in their companies or in the university research labs. So this is the VDEN, an example for a so-called cave immersive system. And we're going to have one of those in our lab at the university and one in the research park, hopefully by the end of the summer. If you want to come and experience it, I will happily invite you and we'll be excited to show you what we do. Current commercial systems cost about an order of magnitude or two more than this. So we're looking into making this a more affordable and more widely used system. And the last step, all the systems that we have right now are really single user systems. We have an MRI for building a multi-user cave system that we're going to have in the research park hopefully later this year. But most of our work is really in software. System architectures on how can we display large amounts of data, be it architectural data with lots of details and the surfaces and the floors and the light simulation, fluid flow, airflow simulation data, mechanical engineering, motion simulation, assembly, disassembly simulation, including augmented reality applications where we combine computer-generated imagery in the real world. So all of that combines both the speed and the interactivity so that we have a world like here, we have a parcel facility that simulates thousands of packages in real time in a way that helps people understand their data and help them better work with all the data that they have. And of course, in the end, sometimes we do make pretty pictures, but it's pretty pictures with a purpose. So this is an example for virtual prototyping for a not so easy to hide German car company. And this is also an interesting example for the impact that this work can have. This is based on a software architecture that we developed as part of Ph.D. thesis and that we open sourced. And then two of our master students went and started a little company that used this as the basis for their product. And then they got bought by Autodesk, and now this is the product that Autodesk sells to all the car companies all around the world, and it still uses some of our architecture underneath it. So we're trying to help and make these things available. We do a lot of open source software, and we like to work with large teams in making all these things sort of available and effective. But not everybody wants to have a cave in their office. Not everybody wants to do virtual reality. So we're also interested in how can we help people use their data in a more conventional way. And one way to do that is web-based visualization systems. And there is a couple of those. And they have many advantages and many people like them, but they're also limitations. One of them is limited expressiveness. They all have the same 5 visualization primitives. So we are very interested in developing new visual metaphors. Once I start paging, if I cannot fit everything on one screen, it's very difficult to keep the context. Our brain is just not good at that. So we need to develop new ways to present large amounts of data to have lots of information on a single screen. And the other limitation is that web browsers are really not designed to process large amounts of data. If we have tens of thousands or hundreds of thousands, not to talk about millions of data elements, interactivity gets lost very quickly, and then the visualization becomes a lot less effective. So we are working on using the graphics processing units to increase the speed that we get inside a web environment for processing. And we have a prototype that gives us about 1 to 2 orders of magnitude faster performance than a normal application. We think there's a lot more potential here for large data visualization in a web-based context. So, as I said, my work is inherently multidisciplinary and collaborative. I don't usually generate my own data. I like to work with other people on how can we use virtual reality or interactive data visualization. So if you have a lot of data and you're not quite sure how to use it, talk to us. We'd be happy to figure out how can we help you better understand the data that you have. More concretely, as I said, we are building a multi-user cave system as part of an MRI, and hopefully it's going to be up and running by the end of this year. And it's a unique system for multi-user immersive interaction. So if you have data that is 3-dimensional, This would be a very interesting way to explore that and try to better understand this in a really unique way. And we're also looking for people that are interested in web-based large data visualization. So essentially, if you have a lot of data and don't know what to do with it, we would like to talk to you. And that's also true for industry. There's a lot of industry here in the area that we're already talking to and that we'd like to talk to do more collaboration with them. Which leads me to the long-term use. I'm the first one, I think, that talks about virtual reality in the seminar series, but I'm by far not the only one. We have actually a fair number of faculty that work in this area, and we think that we can establish UCF as one of the core groups to do this kind of work in the world. And that's what we're working on. And also, we have a lot of industry in this area that are in the Orlando sort of vicinity. So we're trying to work with them and see if we can make this really a major center. Acknowledgements to everybody that helped make this possible. And that's the end of my talk. Thank you very much.
Thank you, Dirk.